Welcome back, class. Today's a big day. All of our earlier lessons have led us to this point because today we begin learning how to solve quadratic equations. Today we're going to learn our first solving technique. It's called taking the square root. Let's get started.
Excuse me, Mr. Caldwell. What's that sound?
What do you mean, Codette?
My audio sensors are detecting a disruption as well.
Teacher, it seems to be the sound of someone singing.
Oh, it must be Mr. Goodman's chorus class. They're practicing outside today because the weather's nice.
Oh, no, not the zombies! How can any of us focus on algebra with the zombies making that hideous racket? Mr. Caldwell, please tell them to stop.
If you feel so strongly about it, tell them yourself.
Don't be ridiculous. Everyone knows a vampire cannot go outside in the sunshine. Listen to them. When I was a young vampire, the choir at the school used to win awards. They sang as beautifully as banshees. Now we have these zombies who sing like they are dying.
Negative. Zombies are not dying. They are undead.
Hey, what's wrong with being undead?
Tom, just close the window and we won't hear them anymore. Now let's get excited about solving some quadratic equations. In our last lesson, we learned what it means to solve a quadratic equation. We said that most of the quadratic equations we've seen in our class until now have had millions and billions of solutions. When we graph them, they make a parabola, where every single point on that parabola is one possible solution. But we learned that sometimes we'll see the same quadratic equation written in a different format. Instead of starting with the y equals at the beginning, the same quadratic equation can be written with a 0 equals at the beginning, which just means that of all the millions of solutions on our original parabola, now we just want to know which ones give us an answer of y equals 0. Those solutions, which we sometimes just call zeros, are just the points on the parabola where y equals 0, the places where our parabola crosses the x-axis. In other words, our x-intercepts. So we learned that sometimes when we're working with quadratic equations, we don't care about the millions and billions of solutions that make the whole parabola. We're just solving for these zeros. So today, we're going to learn our first technique for finding the 0 points. And because of that, we're going to see most of our quadratic equations in the format that starts with 0 equals instead of y equals. Just remember that there's nothing to be confused about or intimidated by when we see 0 equals instead of y equals. It just means that instead of focusing on the whole parabola full of solutions, we're only looking for the answers that give us y equals 0. Today's lesson is about one particular technique for figuring out those 0 points on a quadratic equation, a technique called taking the square root. So let's start by making sure we know what square roots are and why square roots matter so much when we're trying to solve quadratic equations. Now, we've learned that what makes a quadratic equation quadratic is that it has an x squared in it, or some other variable that's squared. That means that every single time we have to solve a quadratic equation, there's going to be an x squared in it that we have to know how to solve. But the equations we learned to solve earlier in algebra usually don't have that x squared in them, so we may not know what to do. And there's something tricky about solving equations that have an x squared in them. We need to make sure we know what it is. Let's start with an example to show you what I mean. Suppose that I ask you to solve this equation, x squared equals 9.
Hey, I think I know the answer. X must be 3. 3 squared would be 3 times 3, which is 9. So 3 is the number we can plug in for x to get 9.
Well, that's true, Bones. Your answer is right. But this is exactly the tricky part that I was talking about. It turns out that 3 isn't our only right answer. There's another number that works too. We're going to end up with 2 answers here. And one of those answers is 3, like you said. But can anyone think of what the other answer might be?
Teacher, you have taught us that a negative number squared makes a positive number. For instance, negative 2 squared is positive 4. You taught us that this is why the negative side of a parabola rises upward in a mirror image of the positive side. Because when we square those negative values of x, they give us positive values for y. So I believe the same thing is true here. There is a negative number that we can square to get an answer of positive 9. Is that correct?
Oh, I see what you're saying, Wendigo. I said the answer was just 3. But negative 3 also works because negative 3 times negative 3 is also 9. So is that our other answer? Negative 3?
I'm impressed. That's exactly right. We have two answers here, positive 3 and negative 3. So we just learned why it can be tricky to solve equations with an x squared in them. Because we need to remember that if we have a positive answer, there's also going to be a negative answer. Let me put this another way. If we look at our equation again, x squared equals 9, what did we really end up doing to solve the equation? Bones solved it in his head and just told us what the answer would be, but there was an actual step that he took to solve this equation, even if he didn't know it. He took the square root of both sides. Remember, the square root of a number is whatever number times itself gives us our original number. So the square root of 9 is any number that, when we square it, equals 9. In this case, 3 is a square root of 9. And we learned that negative 3 is also a square root of 9. We use this math symbol, called a radical, to mean square root. So we can write square root of 9 equals 3 and square root of 9 equals negative 3. We could also save space by writing square root of 9 equals plus or minus 3, which combines those two separate equations into a single equation using this little symbol with a plus sign on top of a minus sign. It means plus or minus, so our equation here is square root of 9 equals plus or minus 3, meaning positive 3 or negative 3. Now, I'm telling you all of this for a reason. Square roots are an important part of solving quadratic equations because, as we've learned, every quadratic equation has a variable in it that's squared. And we're going to get a lot of questions wrong unless we remember that any positive number actually has two square roots, a positive one and a negative one. So today, we're going to practice this by learning our first technique for solving quadratic equations. That technique is called taking the square root. It works really well for some quadratic equations, though it isn't as helpful on others. So in later lessons, we'll learn other approaches. Just like we said that there are 3 different tools we use to help us eat food, a fork, a spoon, and a knife, in the same way we have different tools for solving quadratic equations, depending on the situation. Today's lesson on taking the square root of a quadratic equation is our first tool. It's basically going to work like the problem we just solved. We're going to have an x squared on one side of our equation, and some number on the other side. So in order to solve it, we're going to take the square root of both sides. Let's make sure we understand that idea. Earlier in algebra, you learned that when we solve equations, we have to do the same thing to both sides. Adding, subtracting, multiplying, dividing. We're allowed to do all of those things as long as we do them to both sides. Well, now we're adding this new thing that we can do to both sides. We can take the square root of both sides. We just have to remember that square roots can be positive or negative. It works like this. Say we're given the equation 2x squared plus 4 equals 36. It's a quadratic equation because it has an x squared in it. But at first glance, you might think it's not like the quadratic equations we've seen in earlier lessons. We don't have y equals, and we also don't have 0 equals. But don't be fooled. If we subtract 36 from both sides, look what we end up with. 2x squared minus 32 equals 0. Now this equation does have the same 0 equals format we saw earlier. We just need to find some number or numbers that we can plug in for x to give us y equals 0. So how do we do that? When we use the technique we're learning today, called taking the square root, we just start by treating our quadratic equation the same way we would treat simpler equations. To solve simpler equations, you need to move the x's to one side of the equation and move the numbers to the other side. So that's what we're going to do. It may seem strange to do this, since it's not what we've been doing to quadratic equations until now. Until now, we've been writing the x squareds and the x's and the number all on one side of the equation, with just a y or a 0 on the other side. But let's treat this quadratic equation just like a simpler equation and get the x's on one side and the numbers on the other side. How can we do that?
We have 2x squared minus 32 equals 0. The number 32 is on the same side as our 2x squared, which is not what we want. So let's move it to the other side by adding 32 to both sides.
Good, Codette. When we do that, we get 2x squared equals 32. Then we divide both sides by 2 in order to get x squared by itself instead of 2x squared. Now we have x squared equals 16, and we're very close to the final answer. We just need to be careful because this is the tricky part we talked about earlier. We're now going to take the square root of both sides. We just write a radical symbol over both sides, so we get the square root of x squared equals the square root of 16. On the left side of our equation, the square root of x squared is just plain old x, since square roots and squares cancel each other out. They're opposites. But what about on the right side of our equation? What's the square root of 16? This is the tricky part we saw in our earlier problem.
4 squared is 16, and negative 4 squared is 16, so our answer is positive 4 and negative 4.
That's right, Bones. We have two answers here, a positive one and a negative one. So when we use this technique of taking the square root, we start by treating our quadratic equation just like a simpler equation, which means we get our x squared on one side and our number on the other side. Then we find the square root of both sides. We just have to remember that the square root of a positive number, like 16 or like 9 in our earlier example, will give us two answers, a positive one and a negative one. Now let's see a more challenging example. Let's solve the equation 0 equals 2x plus 2 squared minus 64.
Ooh, I know what we can do. We can use our FOIL technique on the 2x plus 2 squared. That will let us multiply 2x plus 2 times 2x plus 2.
Codette, you're right that we could do that, and it would work, but there's an easier way. Let's use our technique of taking the square root. We start by getting all of our numbers on one side, so let's add 64 to both sides. What do we get?
We get 64 equals 2x plus 2 squared.
Right. Now, the left side of the equation is something squared, and the right side of the equation is also something squared. So just like in our earlier problems, we're going to use our technique of taking the square root of both sides. On the right side of our equation, we have the quantity 2x plus 2 squared. So if we take the square root of something that's already squared, those two things cancel each other out. The square root of 2x plus 2 squared is just 2x plus 2. And what about on the left side of our equation? What's the square root of 64?
The square root of 64 is 8, because 8 times 8 is 64. So that is the left side of our equation, 8.
But, Tom, that's the same mistake I made last time. 64 has another square root, not just positive 8. Negative 8 works too, because a negative times a negative makes a positive.
Right, Bones. So 2x plus 2 will give us the right answer if it equals 8. And 2x plus 2 will also give us the right answer if it equals negative 8. Both of these equations will work, so we're going to have to solve them both. The first equation is 2x plus 2 equals positive 8. We solve it the usual way. Subtract 2 from both sides, then divide by 2. We get x equals 3. That's our first answer, x equals 3. Our second equation is 2x plus 2 equals negative 8. Again, we solve it in the usual way. We subtract 2 from both sides and then divide by 2. We get x equals negative 5. So that's our second answer, x equals negative 5. So these are our two solutions, x equals 3 and x equals negative 5. Well done. Notice that in both problems we just did, the key step was remembering that we were going to end up with two possible answers, a positive square root and a negative square root. We had to solve for both of them. Does everyone understand?
I understand, Mr. Caldwell.
I also understand.
Yes, Mr. Caldwell, I get it, but the zombies are killing me. They're singing in the graveyard right below our window. It is like the soundtrack of my nightmares.
Tom, I can barely hear them. I think we should just live and let live. Are you familiar with that expression, Tom?
Live and let live? Are you being humorous, Mr. Caldwell? They are undead, and they are not letting me live. They are killing me.
Tom, Mr. C is right. Why can't you just leave them alone?
People, these are zombies. They eat people's brains. In fact, I think some of them are eating each other's brains right now, while they're singing.
Hey, I recognize that tune. I think they're singing Beethoven's Ninth Symphony, like the Ode to Joy.
Zombies singing about joy? What's next? Vampires singing Ode to Garlic? Enough is enough. Attention! Zombies down in the graveyard! You are killing us with your terrible music! My family owns this castle, so I command you, go eat brains somewhere else.
Tom, why can't you be nicer? How are they supposed to get better at singing if they can't practice?
Tom, enough of that for right now. I'll talk to Mr. Goodman about it later. Let's get back to math. Let's see a type of problem that uses our technique of taking the square root in a new way. Our last two problems have had two answers, but quadratic equations do not always have two answers. We've seen that some parabolas touch the x-axis twice, which means that they have two solutions. But some touch the x-axis just once, so they only have one solution. And some never touch the x-axis at all, which means that they have no solutions. The simplest example of an equation with just one answer is our parent function, y equals x squared. To find the solutions, the zeros of this function, we change it to 0 equals x squared. And when we take the square root of both sides, what do we get? What's the square root of 0?
The only number that can be squared to give an answer of 0 is 0 itself. 0 times 0 is 0.
Correct, V9. The square root of 0 has only one answer. It's just plain old 0. So this problem is not like the earlier problems we did. In those earlier problems, we had to solve the square root of positive numbers, like 9 or 16 or 64, and those square roots gave us two answers, a positive one and a negative one. But the square root of 0 has only one answer. Think about what this means on a graph. The graph of our parent function looks like this, a parabola with its vertex right on the x-axis. It touches the x-axis only at this one point. This is the only solution from this parabola where y equals 0. And the same thing will be true for any other parabola that sits right on the x-axis. We could shift our parent function left or right to make lots of parabolas, lots of equations, sitting on the x-axis, and all of them would have just one x-intercept, one 0 point as well. They would have just one solution. Alright, we've now seen examples of quadratic equations with two solutions and quadratic equations with one solution. We're going to finish our lesson with quadratic equations that have no solutions.
Oh, how is that even possible? How can an equation have no answers? I mean, if I had a brain, it would be exploding right now.
I understand what you're saying, Bones, but think about this. We have seen parabolas that never cross the x-axis, parabolas that have no x-intercepts. So the equations of these parabolas must have no zeros, no solutions. The question is just, what are those equations? How is it possible that they have all of these millions of other solutions that we see in their parabolas, but they have no solutions where y is 0? Let's see for ourselves. The parabola shown here is our parent function, y equals x squared, after it has been shifted upward by 1 unit so that it doesn't touch the x-axis. Its equation is y equals x squared plus 1. And again, we can see that it has no x-intercept. So we expect that this equation will have no solution for y equals 0. The question is, why does it have no solution for y equals 0? Before I show you this, I just want to remind everyone that I'm not saying this equation has no solutions at all. The fact that we can see this whole parabola for y equals x squared plus 1 proves that it has tons and tons of solutions. Every point on this parabola is a solution to this equation. But what this equation doesn't have is solutions where y equals 0. So let's solve this equation the same way we solved our earlier equations, using the take the square root technique. Let's get all of the x's on one side here and all of the numbers on the other. How do we do that?
Well, if we have x squared plus 1 equals 0, then we just subtract 1 from both sides, right? So we would get x squared equals negative 1.
Good, Ruby. And can anyone see the problem we've just run into? We're now going to take the square root of both sides, just like we did in our earlier problems, and we get this. We know that on the left side of this equation, the square root of x squared is just going to give us plain old x. On the right side of this equation, we have the square root of negative 1. And that is the problem we've just run into. How are we supposed to solve x squared equals negative 1? Can you think of any number that, when you square it, gives you negative 1?
I can't. There is no such number, Mr. Caldwell. A positive times a positive makes a positive. A negative times a negative makes a positive. The only other number is 0, but as the robot said earlier, 0 times 0 is just 0. So there is no number that you can multiply times itself to make a negative answer.
You're right, Tom. There is no number anywhere on the entire number line that we can square and get a negative answer. So whenever we have x squared equal to a negative number, like x squared equals negative 1, we have no x-intercept, no zeros, no solution, because it's impossible for any number squared to make a negative number. That means any quadratic equation that boils down to x squared equals a negative number will have no x-intercepts, no zeros. Yes, it will still have a parabola of millions of possible solutions, but none of those solutions will be for y equals 0. Well done, class. Let's quickly review what we learned today. A quadratic equation that begins with y equals has millions of solutions, which we see in a parabola, because each single point in a parabola is one of those millions of solutions. But if we take that same quadratic equation and start it with 0 equals, then we don't care about those millions of solutions anymore. We only care about the ones that give us an answer of y equals 0, the x-intercepts of the parabola only. And solving a quadratic equation usually means finding those zeros. Since quadratic equations have an x squared in them, we need to learn how to solve equations with x squareds. There are different tools for doing that, and we have to choose which tool we use depending on the type of problem we're facing. The tool we learned to use today was how to solve a quadratic equation by taking the square root. We got all the numbers on one side and the x's on the other side. Then we took the square root of both sides. Then we ran into 3 different scenarios. The first scenario was when the x squared part of our equation equaled a positive number, like x squared equals 9, or x squared equals 16, or x squared equals 64. In equations like those, we need to remember that a positive number has 2 square roots, a positive one and also a negative one. For instance, the square root of 16 is positive 4 and also negative 4. The second scenario we ran into was when we had to take the square root of 0, like in the equation x squared equals 0. There are no positive or negative square roots for 0. The only square root of 0 is 0 itself, which means we only have one solution, not 2, when our squared quantity is equal to 0. The third scenario we ran into was when we had to take the square root of a negative number, like in the equation x squared equals negative 1. In that scenario, we're not going to have any answers, because there are no numbers anywhere on the number line that you can square to get a negative number. When we graph equations like these, they turn around before they ever reach the x-axis, so they never touch the x-axis at all. They have no 0 points, no x-intercepts. So if someone asks us to find the solution to an equation like this for y equals 0, the answer is that there is no solution. Good work today, class! You've just learned how to use our first tool for solving quadratic equations, taking the square root. I'll see you all next time.